This video is on colligative properties. You've got to know the different colligative properties that change and also why they change. So first off, colligative properties depend on concentration of a solute particle, not on the chemical identity. So they depend on how much you have of something, not necessarily what it actually is. So here are your three colligative properties that you're going to know, and as we go through this video, we're going to talk more and more about why. So the first thing is decrease in vapor pressure. So vapor pressure of a solution is lower than a vapor pressure of a pure solvent. So as you add solute, the vapor pressure goes down. Next, boiling point elevation. So this means your boiling point goes up as you add solute to your solution. Freezing point depression. Depression means go down. So this means freezing point goes down when you add a solute. So now the question is, why? So vapor pressure is pretty much the pressure that's caused by the gas in a solution. So in this first beaker, you can tell that it's just the pure solvent, so there's hardly anything mixed in it. So it's able to escape very easily. So this is why the vapor pressure is high. Now over here, if this was actually a colored picture, the green dots represent your solute that I'm adding in here. So the green dots are your solute, and what's happening is that they're getting in the way. So if they're getting in the way of the water molecules turning into vapor, you're going to have less vapor. And because you have less vapor, vapor pressure goes down. Okay, so again, your solute gets in the way of vapor being formed, so therefore no vapor, less vapor pressure. Now this exact same reason is why your boiling point also changes. So therefore boiling temperature increases because a higher temperature is needed to raise the vapor pressure. So you've got to get it to a higher temperature so those solutes can get out of the way and you can get that pressure above what it is. Okay, and then lastly, freezing point. Now this is the most common one that people know about because of snow. So when we put salt on the roads, it's not to necessarily melt it, it's not heating it, but it is changing the freezing point of the snow, of the water. So the number of solute particles starts to interfere with hydrogen bonds and therefore decreases the freezing point. So in this case, this is just a pure crystalline structure of H2O, and it's just simply able to do its hydrogen bonds and it's good to go. This one, if you can see these little dots here, this is representing your solute, and you can see that it's messing up those intermolecular forces, which is breaking down your crystalline structure, and because of that, it causes the freezing point to go down. Now, this doesn't mean it won't ever freeze, it just has a lower freezing point. So salt on the roads doesn't necessarily help with cities and towns and countries or whatever, where the freezing temperatures go into extremely low temperatures. So Alaska and places like that, the salt's really not going to do anything. They have to actually go in and plow the roads and things like that to get the snow to go away. So here's some examples, like I said, salt on the roads and antifreeze for your car radiator do the exact same thing. So the presence of the solute in a liquid increases degree of disorder. So this entropy piece, because remember degree of disorder is entropy, therefore liquid forms solid at a lower temperature than normal. So again, colligative properties, you have to know how vapor pressure, boiling point, and freezing point change, and you have to know why.